Hey, what's going on, guys? I'm a little bit late to this daily question, but and I've already read it, but it's a medium question, construct quad tree, and pretty much what's going on here is you have four different nodes that are supposed to represent top left, top right, bottom right, and then also two values, val and isLeaf, and you're supposed to construct a grid based on that. So for this example where it's 0, 1, 1, 0, you start with your root node, which is you start with the root node. I'm not sure if the value for the root node matters. Let's see. You have value and isLeaf. Oh, these are both true or false. Okay, so isLeaf, notice that you're going to assign the values of true or false. IsLeaf is false. Okay, so I'm guessing this is not considered a leaf since so your first node is not considered a leaf since it's like the parent node, and then all of these other nodes are considered leaves since they're the last node in the question. And then you have the value of, if it's not a leaf, I don't think the value matters. Yeah. So the value doesn't matter if you're not a leaf, but if you are the leaf, your value matters. So all of these that are leaves, their values get put into the final grid. And then for this second example, it's very similar, except it's a larger scale this time, and this is the breakdown of it. You start with one root node, and then they have their own four leaves, and then they have their own... Oh, that was my grandpa. And they each have their own four leaves for this four sections up here. But then this top left leaf is only one here. So, and then since all of these values are the same, you can put them into one leaf and count it as the a leaf. Yeah. And then this yellow node here is not considered a leaf since it breaks itself down into four different leaves as well. So I think the strategy here is to do some sort of recursion. We can start by recursing on the entire box. So we start off with the entire box, and then we split it into four. We recurse into four different boxes, and we keep doing that until the box size is equal to this base case, until the box size is this base case. And once it's this base case, then we can start putting in the leaves in. Right, so we keep breaking it down until we get down to these boxes. And n is always going to be 2 to the n, so that's not an issue. We won't ever have a weird division thing. So let's just do that. Define recursion as the size of the box. I think that's all we need for now. And then we're gonna run recursion on, let's see, we should make n is equal to len of n, or not n, len of grid, and we're gonna run recursion on n, and then we want to return, well, we need the kind of the location of the grid too, right? So let's just put that in. I comma j is the location of the grid. Oh wait, I should put 0 comma 0 here. And then we want to return, so we have size divided by 2 as the next size. And then we can run the recursion off next size comma I comma j. And then we want to add next size to all of these, plus next size, oops, I forgot an t here. Oops, bro, what am I doing? Okay, there we go, put that in. So this should break it down, and then if our size is equal to the smallest possible size, which is 2, then we want to do something. So we want to pretty much do something here. But let's just make sure this works. Actually, should we want to do size equals 1? Yeah, the base case is actually size equals 1, which is the smallest one. Yeah. Okay. So we end up with 2, 0, 0. Since our size starts off at 2, and then, okay, and then we get 4 ones after. Okay, so this is perfectly makes sense. And then we have this node thing, definition for quad tree. Can we just can we undo this thing? Okay, now we have class node. Wait a minute. This is just telling us the definition. Does quad tree node, is it already defined for us? Go to the wiki. How do I call it? How do I call a quad tree? Can I just do this? Like, can I just do root is equal to quad tree, like this? Does this instantiate a default quad tree? Wait, it's not defined. Is it just called node or something? What? I don't get it. I don't get how I'm supposed to use this. Okay, I'm guessing it's just called a node. Is it? It says class node here, so I'm assuming it's just called node. Okay, root is equal to node. And here, do we want to pass in the root node here? Okay, we want it to return a node, obviously. So once we get the size equals 1, we want to return what's at that location. So return the node of how do I set these values? I say like temp is equal to this, and temp dot val is equal to grid of I of j, and temp dot is leaf is equal to true, and then okay, and then is leaf is equal to true, and then return temp, and then I want it to combine it all into the next thing, right? Next size is equal to that, combined is equal to node, combined is equal to node, and then I want it to combine all of them. So combine dot is leaf is equal to false, and then I want it to combine dot top left is equal to this, and then just do this for all of them. Top right, bottom left, and bottom right. And we want to return the combined version. Oops, combined. Okay, so this should work with the most base case, I believe. Oh, we need to set its value too. What is its value? How did I get an integer? I'm guessing here is the issue. What do I set the value to? The value shouldn't matter, right? I just set it to here. It's set to 1, so I'll set the value to 1. Wait, is it always 1? Yeah, it looks like the value is always 1. Wait, what? Oh, no, I mean if it's not a leaf, value is always equal to 1, yeah. Is leaf is equal to 1 here for all of them, yeah, okay. And the value is equal to 1 if it isn't a leaf. Okay. Okay, so now we got it for the base case. Nice. We need to do it for this case where all of these four values are the same. So it's a okay, so we need to code that case if combined dot top left dot val is equal to, and then just spam this, and then spam this, and then make this a new line so it's slightly easier to read, I think. If the top left is equal to the top right is equal to the bottom left is equal to the bottom right, then we want to combined dot is leaf is equal to false, combined dot val is equal to any of these vals, and set the rest of their things to 0. Combined dot top left is equal to null. Null? None? None maybe? Okay, none. Let's spam this. Oops, I didn't mean to run the program. Dang it. I did Control plus and ran the program. Okay, there we go. Wait, did I click? Did I do submit or what's an internal error? Wait a minute, I got an internal error. Oh, what's the issue here? Can I just print combined? Am I like too many nulls or something? My output has too many nulls in it. I'm kind of confused. Okay, well, let me print the combined. Oh, frick. I can't print combined here. I just print this. Okay. Oh wait, it's just a node object. It doesn't actually show. It's not like a linked list and it shows. Okay, let's do some debugging. So we start with the root node 0, 1, and we have 4 nodes 1, 1, which makes sense because the top left is 1. 1, 1 for the top right, I guess. Should be 0, 1. So this combining thing is definitely not working. How about I just print this location here whenever it tries to combine itself. See if the location is correct first. It's trying to combine itself at 0, 0, which makes sense. At 2, 0, which makes sense. 0, 2, which makes sense. And 2, 2, which makes sense. And then did it combine itself at 0, 0 again? Well, it must have. And now it's thinking about 4, 0, which combined itself. 6, 0, which combined itself. 4, 2, which combined itself. That would be right here. 6, 2, which combined itself. 4, 0 actually does combine itself, which it's not supposed to do. How are all the values the same? So we want to grid of I of j. How do I debug this? Combine dot value. Combined dot top left dot val is equal to combined dot top right dot val. I'm gonna try to put in an easier case because this case is very hard to read. So we can try to put in an easier case where the grid is just like this. What if it's just 0, 0? Oops, 0, 0, Let me think about it. What's a good test case to have? We can have all zeros on this side, all ones on this side, and we can have 0, 1, 0, 1 on this side, and 0, 1, 1, 0 on this side. Okay, let's do that. 0, 0, 0, 1. 0, 0, 0, 1. 1, 1, 0, 1. And 1, 1, 1, 0. 1, 1, 1, 0. Okay. Can't shift the case over. Tempted to delete that case. We didn't actually print anything. Okay, so on this case, we got 0, 1, which makes sense. 1, 0, which makes sense. But then on this thing, we got 1, 1 when it should have been 0, 1. So that would be the... How is the thing being printed? I feel like we just have like the right values. Like it's just in the wrong order. Something is just in the wrong order. No, we can't. Can we just not set all of them to none? We want to set it to... When I plus 1 is occurring as the top... Okay, we need to do an even simpler case. We want to do this, but with just this flipped like this. Yeah, we even get this case wrong, because these two are flipped the wrong way. So I must have flipped these two on accident. This should go here. And bottom right, yeah, and this should go here. Will that fix it? Top left, top right. Oh my gosh, I only flipped those two around. I didn't realize that was the correct way to go. Okay, okay, is that the solution? Just YOLO? Let's go for it. Dang it. I outputted 1, 1 in this case. What is this? 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1. Okay. So I failed on this test case. Oops. 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1. How did I get off by so much? So the correct answer should have been well, all of these boxes are different, so it should have had a lot of different numbers, yeah. Is it combining for no reason? Print I, comma, j. Dang it, what am I doing? I forgot to put in the test case. Okay. I forgot to put in the test case, bro. Okay. 0, 0. Because it thinks the value of every val is the same. Top right dot val. But those never even combined yet. Oh, the reason why they're all the same is because we set them to the same here. If they're all 1, or no, we set them all to grid of I of j here. We really want to be checking if they're all leaves as well. They have to... Is leaf is equal to 1. Yeah, so we have to be checking if they're all leaves as well. Or no, we can just check if one of them are leaves, I think. And combine dot top left dot is leaf is equal to 1. They have to all be leaves for this to be combinable, right? Dang it, is leaf. Okay, I'm just gonna be safe and do this with all of them, but I'm not sure if that's required or not. Oh, is equal to 1. And let's put, oh wait, I don't think I need parentheses here. And this is kind of annoying to deal with, the syntax here. I mean, there must be a cleaner way to do this, I feel like. Okay. Has to be a cleaner way to do this, but we'll do this for now. Oh, I might get output limit exceeded. Never mind. Okay, I'd like to submit without this output thing because it might be slowing down my solution by a lot. But I don't even think runtime is a big thing in this question. This question is mainly about implementation, I think, and finding the recursion. There has to be a cleaner way to do this. Like, this is so messy. Yeah, people did similar things. Used the recursion. And my grandpa's not feeling so well, but yeah, definitely something going on here. Oh, he's checking the box itself. Like, he's just straight up checking the box. So I guess that could be better. A lot cleaner solution, but I think I got the right idea. Yeah, it's kind of annoying to deal with all this top left, top right thing. So, but this is a cool question. Lots of implementation, not really too difficult, I think. Hopefully you guys enjoyed, and hopefully you guys enjoyed me struggling. If you made it to the end, thanks for watching, and peace out.